Okay, looks like our record is on. So this is the e-NABLE Education New Members meeting. And we like to talk about both like how to get started with e-NABLE or get your makerspace moving, and also how to integrate things from e-NABLE into educational experiences, whether that's classroom, research, clubs, things like that. My name is Ian Roy, and I am at Brandeis University, and my team runs the makerspaces, and I teach at the intersection of engineering and business. And I've been here about 14 years, and I made my first hand about 13 years ago when I saw John Scholl at a conference. And now mostly we use e-NABLE as a framework to learn open source hardware. We have made between 15 and 20 hands for direct for recipients, but we have less students doing that now. We still have a couple students, like we produce maybe around 10 Phoenix hands a semester as part of a class project. But we aren't directly sending those to recipients. Mostly we try to find like international maker spaces that will take them as touchstones about setting up new programs. But I thought we could start by doing introductions, saying hi to everybody, going around the room, hearing sort of where in the world you are and what brings you to this meeting. And I am just outside of Boston, Massachusetts, so it's 1 o'clock here. Jonathan, want to popcorn it over to you? How's your day going?
It is going well. My name is Jonathan. I've been involved with e-NABLE for probably a little over 2 years now. Um, I kind of help take care of the hub, just random stuff like we had the hub outage the other day, so I helped coordinate with our technology guru to get that all fixed up. Um, I haven't made a ton of devices. I do have one out there to get some feedback on, so I'm kind of excited to hear about that. But I've been printing for a long time, so that's where my history and expertise can come in.
Great to have you here,
John,
Jonathan.
I'll popcorn it over to you.
I'm John Filreis. I'm a industry mentor for an Epics team at ASU, and we are. Last semester, I was an industry mentor for a team making a hand for Sri Lanka, for somebody in Sri Lanka. This semester, I'm working with a team that's looking at how can we use video or iPhone LiDAR to improve the design and fitting process and shorten the cycles to make something useful for users.
Cool. Excellent topic. Do you want to popcorn it over to someone else for intros?
Well, since I know Nitty, it's all yours.
Hi, my name's Nidhi. I'm a junior studying biomedical engineering, and I'm also coming from EPICS at Arizona State University. I'm the team lead for one of the new Enable teams here, so I joined just to get some more information.
Excellent. You want to send it over to someone else?
Yeah, I'll send it over to Jim.
Hi, my name is Jim Savitas, and I'm a recent retiree who has been printing since all of mid-December. Um, I recently finished I'm almost finished with printing a B3 hand.
Cool.
Not quite sure how I did with it, but I just wanted to get learn 3D printing and get involved doing something useful and maybe helping some people out.
Jim, good to see you again. I think I owe you a quick software tutorial somewhere down my to-do list.
Okay, that's okay.
It looks like it's coming along great, though.
Yeah. Well, I had we can get into it, but I've had an issue. I tried to upscale it to 120%. I did get a little impatient with them not having the kit, so I actually purchased things separately, which I probably have enough screws and line and elastic to print maybe 100 hands at this point.
Nice.
So and that's where I'm at. My probably my biggest challenges were the thermoforming,
Yep.
and as you
It
can
looks
see,
great.
it's a little bit flared out here, So I would have to improve on that, but it is functional. Oh, and I was only able to get 80-pound strength fishing line.
Mhm.
But yeah, for the most part, and I'm yeah, and I guess I'd like your opinions on this.
Totally.
Still need to get the foam. Still need to get the foam
Yep.
and
Yep.
the and the bands. But other than that, I
Looks
think it went
very
well.
good. Looks very functional.
The what do you call these things?
The
Um
tensioners.
yeah, the tensioners. Thank you. The tension pins. Thank you. Um, I I was only I wasn't While I printed it at 120, I actually had to go back and use the 100% tensioners because of the screws.
Oh, because the screw also scales. Yeah, the
Yes. Yes.
fasteners also scale in size and then they don't fit. That's a big problem.
Yeah. Yeah. So I think a suggestion would be to whoever designed the tension screws, if they make separate ones at different scales, just that one piece. Um, I think for the most part it would work, but for the most part everything else works. And um, I'm kind of excited that I was able to do this.
Yeah, it looks really good.
Thank you.
Tremendously better than the first hand I put together.
Oh, thank you.
And Sarah's
and
with
with
us
that,
too. I just wanted to let Sarah say hi.
yes. Sorry about that.
No. I want to dig into it.
Thank you.
Hi, I've been a coordinator with e-NABLE for a few years now. I'm on the hub and answering your email questions and scheduling all of these meetings and sending out the newsletters and um, traveling and recording different stories about chapters around the world. I'm currently in Minneapolis, so
Thanks for joining and keeping us organized as always. These meetings would not happen without Sarah.
thank you.
Thank you. I hope all is going well with you in Minneapolis these days.
Thank you. We
Yes, please
appreciate
stay
that.
safe.
Yeah.
So Jim, maybe we could dig into your things here.
Okay.
Generally, I recommend students build at 150% scale. I think
Okay.
anywhere from 120 to 150 is a great place to start.
Okay.
I built my first at 100% and it was really difficult. It took a really long time. 120, you're helping yourself out. And I do think that one of the big pain points is that the fasteners scale with the hand scaling. And sometimes the pegs fit okay when they scale. Sometimes they also need a little bit of like tolerance on them for the joinery to fit. How did the finger joinery itself fit for you?
Oh, perfectly.
Excellent.
Oh, perfectly. I bought the mini files, the file set from Harbor Freight,
Yep.
and tweezers as well. As you can probably see, I didn't trim. I didn't trim the strings.
Yep.
Yet, and I didn't glue the strings. The tweezers really helped with tying the knots because these fat fingers, really can't do that. So I suppose I'm learning to operate like a surgeon.
Yeah.
With tying with the tweezers. So yeah, I recommend that to any
It's a
newcomer.
great tip.
And like I said, you can see how it's like not flared correctly.
The thermoforming is really difficult.
Yeah.
Did you use the hot water?
No,
method?
and that might be the point. I mean, I actually use the heat gun that I have.
I prefer the heat gun myself.
Yeah. Yeah,
So we had a student make a jig that we use like a
Yes.
soldering reflow iron on.
Oh, yeah. I used the jig. I did print that as well. It's around here someplace.
So we took that and we inverted it. So the student draped that, used that as a drape in Rhino and created the negative space.
Oh, okay.
And then we
pressed it.
place the flat piece on and we apply the soldering reflow like heat gun. And then we push into it with the
pressed it,
original
yeah.
piece. Yeah.
Yeah. That's sounds like a much better way to go. And then but that's really it. I think I did okay. Not quite sure, but the angle.
It looks about right for the stock model. And the closure looks quite good.
Oh, okay.
One
Okay.
of the things I recommend for more ambitious students is to make one that fits their own upper limb.
Okay.
And seeing if you can like change some of the proportions so you could operate it,
Okay.
which is
And
sort of fun. You can see the limitations. You can use the tensioners to tune finger shapes for different activities. But great way to learn the platform. Looks like an excellent first outcome. And you did that on a Centauri Carbon from
yes,
Elegoo.
yeah,
How are you
that is
liking the
true.
machine?
Oh, I love it. I love it. I maybe have at this point maybe about 30 hours on it. My son probably has double for printing stuff for his girlfriend
Cool.
and I printed a few interesting things, but this was really um, you know this is really why I want to do this. And make some kind of contribution in my retirement.
Do you have an account on the hub too, where you're starting to see all the chatter?
On the hub, yeah. Well, yeah. On well, which is the hub? I mean, the
The
enable.
hub.enable.org.
I mean, I am signed up. Obviously, I'm signed up with.
Yeah, you found us here.
Yes. So I'm not quite sure if that's the hub, but
Definitely. And Jonathan administrates a lot of that. And it looks like you're close where you could make a video of that and post the badge. Jonathan, is that about the assembly bar you're looking for?
Yeah, it looks great. Yeah, that's kind of the major points is to make sure that it's all put together, including the padding and the straps. Then, like you said, the angle. I was actually surprised when I built my first one. I figured that like the relaxed state would be more straight, but
right,
most recipients actually prefer a much more angled so that when it's flexed, when the fingers are closed, it's a lot more straight.
right, right. And then that's the thing. I mean, with the fingers completely closed, I'm still, I'm at a downward angle.
Yeah.
So
Have you
Yeah, it
tried to
looks
pick
good
up
though.
a water bottle or grab a door handle with it?
um I'm not having a lot of luck because I don't have the grips.
Yeah.
So
Yeah, slips. Yep.
things tend to slide off. But let's see. Well, I guess a
Yeah, pretty good.
grip.
No, it's a great first build.
Thank you. Thank you.
And I
So
think when
yeah,
you're ready to talk about finding a recipient, I think Jonathan can help you with your hub account and
okay,
looking for, I think probably the lowest barrier is people that are already reaching out on the hub that you could connect with.
okay,
And there's all sorts, right? There's the whole spectrum from directly working for clients to working for spaces that are getting started, and helping them have a touchstone that they can show to a client or something like that.
okay. I'm open to all of it. So
Cool. Maybe we can circle back. I want to check in with John and Nitty. What I think you're both here about the same topic, which it sounds like is using mobile devices for some sort of 3D scanning to get better fit. Was I hearing that right?
Yeah, that's the. Oh, hang on a second. I'm Whoops.
You're blue.
Hang on a second. Yeah, I don't do video. Um, I've got two teams, both of whom were told they should get on the enable call, and
Oh, cool.
I'm questioning
And so
which one
Nitty,
I'm
you're
here
from
for.
one of those teams.
I'm for both of them.
So John, you're working
Yeah.
with you're consulting with two, and Nitty sounds like a leader on one of those teams.
Separate. We work
Okay.
in the organization, but John manages two other teams, and
Okay.
I'm on a separate team.
Okay. I know they have a bunch going on at ASU. That's great.
Yeah.
I'm sorry. Yeah, I was looking at my thing for the other team. Yeah, you want to talk about the Indonesia team? Do you, have you dealt with them before that since this is my first semester with them? Have you dealt with what they're doing before, Nitty?
No, they're a stage 2 team though, and I think they're trying to start printing, if I'm correct.
Cool.
So they have a hand that's not based on the e-NABLE design. And they're
Are they using
trying
the
to,
Open Bionics or something with some motors or another mechanical device?
I think they are looking to have it motorized.
Cool.
They're working with a university in Indonesia that is doing another part of it. It's more than just the hand, it's the full forearm in
Cool.
some fashion. Honestly, I haven't seen enough details of it to fully grasp it. I haven't seen what the Indonesia team's doing. I think that's the big problem right now to get started on the semester is figuring out what's being done at ASU versus what's being done in Indonesia.
Yep.
And then they have some improvements. Their hands a little more block-like, at least from what I saw from last semester's picture. So I'm kind of still coming up to speed on it.
Cool.
My other team is doing the fitting and trying to use optics, LiDAR, whatever they can do off a
Yeah.
cell phone to
Super
help the
cool.
fitting process.
We're super into 3D scanning here. The technology is getting so good so fast. I'm
Mm-hmm.
curious if you know, like, if there's an app that they're finding more useful.
Well, this is the first semester team, and they started a week ago, so
Okay.
they're they have
I
to go
guess you
through the
sort of
whole
have
process of laying out requirements and planning a schedule,
Yep.
and they got a lot of work to do before they know anything.
There's a bunch of really good mobile 3D scanning apps. And they sort of, like you outlined, the two big categories are things that use the time of flight LiDAR sensor, which are usually a little lower resolution for something like a hand, work fairly well because they're tuned for like more of a face kind of geometry. And then the photogrammetry on phones, where phones have an excellent photo sensor at this point. And there's some really great photogrammetry tools, but that's a lot more labor intensive for the capture.
So if you have any links you can
Yeah,
aim me at, that would help.
totally. So I think one of the best ones that we've been getting good results with is Reality Scan, which used to be from a company called Reality Capture, and then was acquired by Unreal Engine, sort of as the whole pipeline into game design. And they have an excellent 3D scanning by a photogrammetry app, and they have a mobile app too. So I put in their thing there. And their mobile app seems to be one of the better photo-based mobile apps. And you could try the time of flight LiDAR, but I would think that maybe it'll work. You're right at the edge of resolution for the time of flight sensor, from my experience, where you get a pretty realistic image because it combines both time of flight LiDAR to get geometry and some photos to get some color on top. But usually, if we look at the triangular meshes, they're not super accurate. It's borderline. It would be cool if you could see if that's usable. The photogrammetry, you can definitely get something usable, but it requires a huge amount more capture data because you've got to take photos all the way around. And then also processing data because you're taking those 2D photos and doing photogrammetry, which essentially is like doing trigonometry to figure out where the points are as the images overlap.
Okay.
And the best mobile, or one of the top mobile photogrammetry apps that we've experimented with, is that Reality Scan app. It seems quite good.
Yeah, I just looked it up while we're talking, and it looks like you can just get it off the Play Store.
Yep. Yeah, I believe it is free. And Reality Scan and all Unreal applications are free for EDU if you ask, which is really nice. Other mobile scanning apps. We've had a bunch of people use Polycam and have good results with that as well. And it really excels at more like human artifact and room scale, like chair scale or like space scale. It seems to be a little better at. And I know there are a bunch of apps that came out of the pandemic for like scanning a face to do PPE fittage and things. And those use the time of flight sensor and are very fast, but they work pretty well at face scale. And once you get down to something as small as an upper limb difference that might have a partial digit or a final appendage with some flex. That might be on the edge of what's possible with just the LiDAR sensor.
Okay.
But I'd be very interested. I know this is a huge pain point in e-NABLE. If we could get measurements that are higher quality from recipients, there's a lot more that could be done in custom fit design. So I love that topic, and I think it's a great one for them to explore.
Well, we're trying to get the professor who runs it is talking with John Schul about being our community partner for it.
Amazing. Yeah, that would be super cool. And something you could contribute back, a best practice. And the other question is what you do with that 3D shape once you have it with the e-NABLE models. So you get some sort of 3D asset of the upper limb difference. And then what tool do you bring that into to adapt what public model? And that would be another really interesting conversation.
The first thought, I mean, where this came from was I was working on the team last semester that was doing an e-NABLE hand, and they couldn't get much of any useful information out of the folks in Sri Lanka. And you know, thought was if you could get the scan, you could then 3D print their what you're attaching to. Because one of the things I noticed watching the students um, experiment with what they had built, just like what Jim was doing earlier, you can't test it the way the user is going to use it.
Yeah.
Right. Because you don't have the same physical configuration. So make a 3D printed model of them, use that to test the hand you're making. That would work, you know, help the fit right off the bat. It'll also help you test the movement if
Yeah.
you can make your mating piece correctly.
Yeah. Makes me think maybe you need like a couple different actual captures from the
Yeah.
recipient, like maybe three, like one in a neutral pose and one in an up and a down pose or something.
Well, I don't know that it's a static capture. Maybe it's a video. Maybe, you know,
Yep.
because part of what,
Well, you could feed videos into a lot of these scanning engines
yeah,
now. The
yeah.
other one
So
that seems to do very well with video is Agisoft's Metashape. And that's what we teach when we teach photogrammetry. This is my favorite software because there's so much documentation and it can really do a lot. And they're building photogrammetry in a ton of other software engines. But what's nice about Agisoft is it does run on a desktop, but it runs on Mac or PC, and it's photo acquisition agnostic. So you can put in photos from a camera, from your phone, from a DSLR. You can correlate LiDAR data sets with photos. It's pretty nice.
okay.
So you could input, I think in both Reality Scan and Agisoft, they can now put video files as the input format.
Okay. Let's see what else was. I'll pass all this on to the team. Like I say, it's going to be a while. They've got to get organized. They've got to get requirements together. They've got to
Yeah.
do a bunch of research, and it'll be a while before they get anything. But this is all good. Everything I've heard till now hasn't been as positive as what I'm hearing from you.
The
As far as
utility
when
is
it comes to
huge.
the
And I think
function.
there's sort of like three technical hurdles that I'm hearing as we talk. One is what geometry to acquire from the recipient. There's a quest like, so from a design perspective, like what measurements are meaningful to have as design inputs. Then there's the how, okay, now we know what data we need. How do we capture it? What's the right sensor type and software
Yeah.
workflow to get that data into a digital format? And then there's, I like your last question, your last answer about they're going to use it to mechanically make a facsimile and design like creating a test rig or something. I like that you bring it back to the real world for the testing. Because I was thinking like, if we're going to stay in software, we probably have something that works natively with meshes, maybe using NURBS as a basis more than like parametric solid modeling. So like that would be something like a Blender or a Rhino. Because you could take, because you're not going to have a parametric file at the output, you're going to have a mesh, like a fixed file. So then how can you use that as a cutting or bending tool with the public also mesh tools, which will probably be using like a Rhino or a Blender type software.
Okay,
But
you're in a different language than me right now.
so it's sort of like how we would like bend. So we take the Phoenix V3 hand, and we've got to mold it against your digital asset from the recipient. So how do we use the digital asset from the recipient as something we can maybe drape that cup around digitally? I like though how your team is thinking, how do we think about that physically? We skip that whole digital step and then we just take the asset, we print it, and then we use it with a physical device to shape it around.
Well, keep in mind, I'm 100 years old and I think like a dinosaur, and a mechanical engineer, so that's pretty straightforward to me. Whereas, you can only get so far digitally, but I've worked with designers who have done exactly something like this and then discovered, yes, it fits on, but it doesn't go on. It
Right.
fits around it, but there's no way to get it in.
The donning and the doffing is, yeah,
Yeah.
totally.
So there are challenges with digital that become
Yep.
immediately obvious when you've got a physical model in your
It's a
hand.
great point. No, and it's also about how do you leverage the learnings from this team so that others can capitalize on it. And maybe
Yeah.
that's something that's easier to teach other people how to do.
And learning, again, going back to learning, this is a class at ASU. It's a bunch of students. They're starting first semester. It's going to take time, and they're going to have a lot of learning paths that they go down that aren't necessarily a straight path from here to a finished product here. So, yeah, don't expect anything at the next phone call.
Well, and so I wonder if we just kind of go into the future of what this technology could do. What is the minimum data set that you can get useful measurement information to do this process? I like that you're thinking video. Like maybe it's like pretty accessible to ask someone to capture a video.
Yeah.
Because I know like more and more people are able to render 3D shapes from a very small amount of photos. And
Yeah.
sort of the standard e-NABLE guide is a couple photos from like different angles. And the other question is like, could we somehow use some AI tools to input that video or input those minimal photos and get a useful geometry out of it? Like, what's the minimum data capture required?
Yeah, I think that's, we got some computer science students on it. I think that's part of the path they're going to go down. Somebody I know from my full-time working days um, knows somebody who does video of kids' heads at parties and prints
Cool.
3D busts of them
Yeah.
uh, in real time. So, he's got some of this capability if I can ever get a hold of the guy. But around ASU, there's probably 100 data science and video experts and those kind of things floating around.
Yep.
So part of what they're going to do this semester is go find nearby help who has this and has some of the tools right there at ASU.
That's great. No, access to a network of experts is huge.
Yeah.
And that also makes me think, so then what's the minimum data we can put in and shape the locked sort of design files from the e-NABLE assets into something custom? The other part is scaling. It probably has to go up or down. That comes back to what we were just talking to Jim about, the joinery, right? Like all the fasteners also scale. And one thing I've been trying to find a team that would participate in is how do we somehow make it so that we can take these out. Most designs, we don't have the original CAD files, right? We have like the output STLs or OBJs. We have those triangular mesh files. And when we scale them, they all scale the same, right? Like the screw holes scale, all the fit scales. Is there a way that we could somehow classify which parts of those models are joinery, which parts are fasteners, and keep those fixed?
Yeah.
So that's the same kind of sides that you and Jim were talking about, from the how do we adapt it to someone's unique physiology and so that the hardware fits it all.
Shouldn't be too. I mean, you do it in an Excel spreadsheet with certain cells stay fixed and certain cells
Yep.
Scale with, as you progress through the spreadsheet, just by putting a dollar sign in front of it. There's got to be a way to do that with data in these apps.
Yeah, I attempted that. I could not figure that out, but I'm here on Long Island just getting started with this. But so I finally decided, you know what? Let me just print the 100% tension pens,
Yep.
and I'll know it'll work. And the tolerance, there's really no play. There's really no play in the, I guess, holding piece here, between that and the tension pen. So it's still a pretty tight fit.
So I think so the field that we're talking about is how to go from like a triangular mesh file back to a parametric file. And there are very expensive tools that do this. Like Geomagic Design X is probably one of the big industry ones that can take, and it's made for working with industrial 3D scan files and then turning them back into parametric solid models that then you can classify elements of the model with. But I just Googled quickly, and I've never tried this, but there's starting to be some AI tools that do this, maybe for much cheaper. So I think someone is going to solve this problem in the next couple years for e-NABLE by finding a really accessible, like off-the-shelf tool. Where we used to have to buy one of these like super expensive ways to do it. This is one of the tools that I like a lot in 3D scanning. Again, a super expensive tool, but Artec makes excellent like analysis grade scanners. Good enough to do academic analysis. And they've now integrated Design X where you can 3D scan an object in and then turn it back into a parametric file. That also means you could input a mesh into their software. So we could like take any of the e-NABLE assets in, and if we've lost the original CAD files or we don't have access to them, we could make it parametric again and then classify this is a screw. Really interesting technical challenges. And you mentioned there's also another team. So Nidhi, I wanted to get back around to you about what your team is focusing on.
Yeah, so we are trying to print out like 2 or 3 of the Phoenix version 3 hands just to kind of identify any like sort of issues or improvements that we can make. And we're planning on doing that this week so that next week during our meeting we can kind of be like, okay, we think we can help improve this hand the most out of the other two and kind of work towards improving that hand and reprinting it with the different customizations or adjustments we decide to make as a team. And then eventually we want to be able to like have the new improved version of this hand and be able to connect it to like a family or maybe a kid and get it like sized properly with them so then they can like, fully use it or fix any issues that they see in like usage because obviously none of us are like going to be able to use it to its full extent as someone else who is able to. And so that's kind of what we're working on towards right now. And we were wondering who we can directly contact in the e-NABLE organization during our process, like going through this project.
So you can use the hub.
Okay.
But I would say if you're looking for an interesting project in e-NABLE, I would go to one of the town hall meetings. The same way you found this education meeting, the town hall meetings, maybe you've been to one, they run through all the open projects. So any recipients that haven't been connected to someone, that's where they connect. And Jonathan is very active on the hub about seeing those. So you could see, if you're looking for a use case, either town hall or talking to Jonathan is probably the best way to find an active recipient that is reaching out where they're sort of already there and asking for things.
Yeah, okay. That sounds great. And how often do the town halls usually like happen?
Are they every 2 weeks, Jonathan?
So we do them before every meeting on the calendar. We meet for a half hour.
Yeah.
Okay, cool. Perfect.
So it looks like on the calendar, the next one is a week from today at 11:30 Eastern.
Okay.
The other thing I'd point out is if you go to this NIH 3D site, this is a little older. We got to keep up with it. But as of 6 months or so ago, these are most of the 3D models from the e-NABLE hub in a collection that you can look through a little easier than scrolling through the device inventory, which is kind of large. But you might find pieces of hands that connect to your platform, like ways we could remove fingers to make them easier to actuate, or change finger shapes, or change palm shapes. There's a lot of like hand accessory bits. Some of them are aesthetic. Some have like stars on them or other like fun geometry. Some are functional. So you could look through there to see some opportunities where people have looked for ways to improve the stock models.
Okay, sounds good.
And I recommend to everyone, I would say make a hand that fits your upper limb. And that's a great, and maybe it has to be 175% scale to fit. But I think trying to do tasks with one, if you don't have an upper limb difference, it should work at least as well for you as someone who does have an upper limb difference, and try to live in it and see what opportunities you see.
Okay, great. Thank you.
Jim, one of my challenges, and I got to do this at some point when I have a minute, I want to make two, and I want to like go about my normal day, like at work, and see like what I encounter in my built environment that works or doesn't work if I'm living in two of them. And one of the things that our students often find when they start exploring this space is that everyone gets into e-NABLE to build upper limbs prostheses for people who need them. But then we usually find out that what we really need is a better doorknob, right? Or like a better can opener. Like it becomes an occupational therapy task that is better solved by something targeted at that task. And I would point to everyone again, when you get into that conversation, Makers Making Change is one of the bigger repositories that can target around specific areas of those occupational therapy tasks. Occupational therapy being the things we do throughout our life. Like our life by occupation, it's the daily tasks that you do. The other thing that's exciting, I think, about this space especially for like young engineers and students studying entrepreneurship is when we solve something as an assistive device, we often solve something for everyone, right? Like accessible design is good design for everyone. So there's some things on that Makers Making Change repository that can probably help everyone. Any other topics we'd like to go back to? We have about 20 minutes to have more discussion on any topics people are interested in.
I just wonder what my next steps are after having.
So if you have that, I think the last steps are to put the padding and the straps on.
Okay.
And then you would go through the badging system on the hub, which Jonathan is the administrator for. And essentially you make a video of the hand in action. And then you get like a badge that shows that you are able to make hands, which then allows you to match make with people in need on the hub.
I see. Okay.
And so you can autonomously like see people posting, there's posts every day, and start to have conversations. Or like a little more targeted, you could go to one of those town halls where Jonathan and John and usually some other folks will run through the unanswered requests and try to like connect people with resources to unanswered requests.
Okay.
And I think the other key is when you start working with recipients, especially in your early builds, is to find one that will give you feedback. And I think most of ours, I think like half of the hands that we've actually made for people here have been one and done. Like we ship it, we don't hear back.
Sure.
I think the better you get better and they get better results if you can have that dialogue and get that like iteration and refinement. And then that discovery that actually we need a better doorknob, and then get into that conversation.
Yeah. Yeah. The thing I'm concerned.
Oh, sorry, lost you.
I used to do that at work all the time with the mute. The thing I'm concerned about is one, I think my my machine is only about 256 millimeters
Yep.
Okay. So, building, let's say, a forearm piece, I don't know if I would be able to do that.
Totally.
And the other thing has to do with, something I brought up before regarding screw holes and things like that,
Yep.
scaling those up. So those I see are the challenges. I think everything else I can take care of.
So for scaling up in Elegoo Slicer,
Right.
it's a fork of Orca, right? So it
Yes.
does have the ability to split pieces up and add dovetails or pegs in the slicer.
I see.
And that doesn't work for everything, but for some
Right.
things, you might be able to chunk it out into
Yeah.
multiple build plates and create the joinery to have it fit back together.
I see.
And I don't know if that would work for like the Kwawu arm perfectly, but I think there are bigger things that might work well for.
Right. Yeah. I attempted to try to figure that out with the tension pins, but I had no luck. And like I said, it was just easier to, take the hit on the 20%.
Yep.
And just do the 100%. Use the 100% tension pins.
You can
the other
always
thing,
reach out on the hub too.
oh yeah, that's true.
I know I have a bigger printer, so I've printed out a couple forearm pieces for people around the US and then shipped them to them.
Okay.
So like one individual, I think she was in Florida or something like that. I printed out the forearm piece because it just barely fit. I have a 350 by 350 printer and that was a close fit.
That's a
But
great
something like
point.
that. I think she had posted on the hub asking if anybody would be willing to help. So I just responded right in there and she sent me the file and it was easy.
Okay.
The other point with some of the geometry, have you played with modifying any of your files with like lightweight CAD? Because you could do slight modifications because you don't have too many spots that you need to put a fastener, right? You could scale that part up and then modify the fasteners back down in something like Tinkercad very rapidly. And so Tinkercad is an online CAD tool, which if you haven't played with, even though we have access to all these crazy CAD tools, sometimes Tinkercad is the fastest way to get to a useful output. And particularly so for something like that, with like you only need 4 screws over the hand, you could import the model into the web browser and then scale it up in the drawing tool, and then add new screw holes that are the smaller size, like over the old screw holes. And that's like a first time you do it under an hour task. Once you get good at it, it's a very rapid task. And the point, these are sort of cheats to get to a printable file.
Sure.
Like maybe that's not the most like shareable file, but
Right.
that's a file that you could get output very rapidly.
Right. Okay. I will look into that, and I'll look into see if I could redesign these pins and just replace them.
Let me give you a resource there. We're actually doing a project in our engineering class this week where people have to import and remix models quickly. And we're using both Tinkercad and Onshape. And I know I have a resource for this. Let me see. Okay, so here is a couple pieces from my documentation. A video about how to import STL files into Tinkercad. Really nice which buttons to press kind of tutorial. And then as Tinkercad does have a limitation where you can only put in 25 megabyte files that are up to, I think, 300,000 triangles. And I doubt you'll hit the file size limit, but you might hit the triangle size limit. And so there's a how to simplify models video there using a tool called MeshLab, which is a great mesh handling Swiss Army knife. It lets you resize models, simplify, and then you can get them uploaded. And then if you got super ambitious and you really wanted to go as far as possible and like re-release a really nice parametric model, you could also use a free tool. Like there's lots of great CAD tools, but probably the most accessible parametric one for ease of use and not too much software barrier. We've used Fusion 360 and SolidWorks, but now we're trying out Onshape a little more. A much more complicated tool, but that has the ability where you could re-release that file if you really dug in. And one of the reasons that I like this is their courses and training area. So if you've got a bunch of time and want to get like the black belt in 3D design, they've got a on-ramp that you could also then translate into SolidWorks or into Fusion 360, sort of like Photoshop, GIMP. Like they're all the same kind of tools with, they call the buttons slightly different things, but they all sort of do the same things. What's nice about this too, it runs on a Chromebook, it runs on an iPad. You can run it from anywhere as long as you have an internet connection. And we're tool agnostic. Like I probably know Fusion 10 times better than I know this, but you're sort of looking for the same buttons and the same workflow.
Yeah, I understand that. Most of my experience is dealing with slideshows and financial programs. Zero engineering.
Well, so you might like that learn.onshape because it starts, there's a new to CAD section, which a lot, like not every tool has such a nice on-ramp with free, and you can use the tool for free when you're getting started.
Thank you.
Yeah, I bet with Tinkercad, if you threw an hour at that Tinkercad, you could very quickly get a usable print. And then you start to be like, oh my goodness, I could remix anything and add things together. It unlocks a lot really quickly. And it's a slippery slope. Like I'm sure it's just all your time, all your money very quickly into these hobbies.
Ian, I have one more question for you.
Totally.
So do you know anything about the EPICS program at ASU?
I've seen them come to these meetings a bit, and I've talked to the faculty a bit who oversees that program. He's been at these meetings a couple times.
Do you know how the community partner process works?
Not really.
So our professor, Jared, is speaking to John about e-NABLE being our community partner for this video capture to CAD program.
Cool.
Would you be willing to be on that community partner team helping us? Because what you've said already is more than I've seen anywhere else
Yeah.
on.
So I'm
ideas
happy to
about how
help
do that.
with the 3D scanning part and the breaking. I'm happy to be like a mentor for the students. I teach a whole semester class on 3D scanning for our anthropology department. And I built it with who was then the head of anthropology. So like a subject matter expert who does real archaeological digs. And I was like the technologist, and we do 13 weeks of 3D scanning techniques. And the final output of that class, the students have to go to a museum somewhere in the world and navigate access and operate in the field and bring back a data set that they do a report on. So they have to do a scan in a museum. So it's the class is called Culture in 3D, Theory, Method, and Ethics of 3D Scanning and Printing the World. And I'd be happy to unpack all of that methodology.
That would be spectacular. So
the problem is it takes a while. So I can connect people to resources, but you got to practice. And even the data capture takes a long time, and then the rendering takes a long time. So like I'm happy to go through it, but it's sort of like challenge by choice if they dig in.
well, what we really need, we need a community partner they can ask questions of.
Yeah.
And give them advice on, what's the right thing. Because ultimately, if this works, they're going to either unleash it on the world as a product, like an app that's sold, or they're going to do something through e-NABLE, since you're one of the biggest, getting this out worldwide. So ultimately, you're a user of it.
Yeah.
And that's what they need is, I'm there as an industry mentor with zero experience on video capture or any of these other technologies they're doing. I just came up with the idea because I was working on a hand last semester.
Yeah, totally. Connect me. I put the email in, and I can run through like a slide deck on any of these technologies too.
Okay. I will give your name to Jared as he's getting that part of it organized, and appreciate your help here. That would be great.
And
Okay.
same thing, Jim, I know I owe you a rundown with any of these technical things. We have our big hackathon starting tomorrow. And so that's taken up our whole semester start. We have a 48-hour event for like 250 people this weekend. After that, our whole team gets way more free. So we can start to do some of this, like connect us with people and talk about software and hardware a little bit more. And if any of you are ever in the Boston area, you should definitely come through Brandeis. I know Jonathan and I have talked before. We always love to visit other people's spaces and then show people around like what we're doing. I just last week today, like 7 days ago, I went to Wellesley College's new maker space. That's unbelievable. So they had shut down their whole library, like a library with millions of books in it. They moved all the books out and remodeled it. And one of the big changes was revamping their makerspace. So we just saw Wellesley's new makerspace, which is super cool. And I can't wait to see them build into it. So yeah, Boston area has a lot of geeks with a lot of hardware who like to share best practice. There's too much for all of us to know anything. Everyone sort of has a different specialty, which is one of the benefits. Like as we explore, like even what to do with this e-NABLE data set of models, there's so many different ways to dig into it. Any last topics in our last 5 minutes or so? Well, I think, Jim, you got some next steps. Jonathan is probably your best point of contact. I thought he shared his email in here too. But the hub is probably the place.
Yes, I have been working. Jonathan's been very helpful, and he kind of initiated me into the whole organization. So thank you for that, Jonathan. And it's given me a lot of advice.
And John, it sounds like you've got a couple breadcrumbs for your team as well.
Yep.
Our next e-NABLE meeting is a week from today for a town hall for anyone that's looking for interesting projects in the community.
Actually, the February calendar is not set yet.
Oh, okay.
So
I was just peeking
if
somewhere around there.
if you're looking at the hub, that's not
Okay.
that would not yet be accurate. But wait, so the February education meeting is the 19th at 1 p.m.,
I
right?
think that's correct. I think we had
Okay.
corresponded about that. Let me double check my GCal, make sure I have it. Yes, but we'll be back on February the 19th at the
Yeah.
same time.
And for sure the next town hall meeting is going to be before Bionic Design on February 12th, but I don't think there's anything
Okay.
on for the first week of February.
Cool.
So, yeah.
Well, thank you so much, Sarah, for keeping us organized and on time. And I'll see you in a little under a month.
Okay, great.
Thank you.
Great to see everyone.